Okay, CNT140, we're looking at Chapter 11 on fiber optic cabling systems. 11 is going to kind of be the introduction to a lot of different things. We're going to come back in future chapters and dig into more specific. So we'll treat this as kind of an overview of some things. Alrighty, with that said, let's dig in. One of the first things to talk about is which fiber optics. Our fiber optics are actually used in quite a few things today. Long distance and metropolitan phone systems, absolutely backbone in our backbone of our networks, plus other backbone of cable TV networks and so forth. Lots of applications for them today. I like to right off the bat remind you of something that you should hopefully remember from 120, fiber to the home. A lot of our internet connections to our houses and our small businesses and so forth are actually a fiber optic connection from your ISP to the side of your house or to the side of your premise, and that whole network is fiber optic, and then inside your home is the last little piece, copper, if you will. So I threw a couple of these in here to remind you about, yes, even our residential and small business connections are fiber up to the side of your house, absolutely. The type of fiber used depends on things like the distance needed, bandwidth necessary, and immunity to interference. If we have anything over 100 meters, we pretty much need to use fiber optic. Copper unshielded twisted pair can go 100 meters. Anything above that, we need to consider using fiber optic. Bandwidth necessary. We have standards for 100 meg, gigabit, 10 gig. They're working on more, but it's very conceivable in the future. Most things are going to need to be fiber optic. It's hard to tell. We don't have a crystal ball yet. But as we start needing high bandwidths of things, fiber optic is the key. If we have any interference problems or noise problems, electrical noise, whether it be in an industrial environment or whatever, manufacturing industrial environment, fiber optic is going to be the key for interference from that. They break it down a little further and talk about outside plant and inside plant. So outside plant, this is your connection from your ISP to your house, to your business, that sort of thing. Most of that cabling is outdoors, so that's outside plant, and most of that's going to be single mode using laser light source operating at higher bandwidths or longer wavelengths, if you will. Cables are spliced in long continuous runs. So if they do have multiple pieces of fiber that they're installing to connect building A to building B, they're probably most likely going to splice that fiber in the middle using fusion splicers into one long run, and it's then tested with optical time domain reflectometers. Hopefully you remember testing our copper cable for distance. We used a TDR, time domain reflectometer. Fiber optic uses the same concept with a pulse of light waiting for it to bounce and come back, if you will. So they call it an OTDR. Actually, there's two units, and they send and wait for the signal and so forth. And this is all basically for outside plant. Again, a lot of times single mode fiber connecting building to building, that sort of thing. Expensive systems, expensive cabling, expensively install. Meanwhile, inside of a building, or premise cabling inside of a building, these are usually simpler, shorter runs, shorter links, a lot of times only connecting closet to closet, switch to switch kind of thing. So most of these are going to be multi-mode fiber using inexpensive LED light sources. With this, their splices are pretty rare. Things are usually just a connector on the end, connector in this closet plugging into this switch, connector in the other closet plugging into another switch. And a lot of the tools and hardware necessary for this is relatively inexpensive, and installation is relatively easy to learn to do. So they also go on to say some of these things are actually combined. So I use an example of a college campus. It's very possible if you have a college campus, think of something like Penn State. Lots of buildings, lots of land. If you're connecting two adjacent buildings together, or even connections in a building, that's going to be multi-mode fiber. But as I start connecting buildings across the campus, a building on this side of campus connecting to a building on the far side of campus, that's going to need to be single mode fiber because of the distance. So a lot of times there is actually a mixture of things in there. Fibers used for, they talk about using fiber for utilities, college campuses, traffic control systems, etc., etc. So fiber and I broke this out a little bit. The book didn't talk about it in too much detail, but I broke it out a little bit more. Fiber tends to be, this is when we tend to choose fiber over copper. Fiber tends to be when we choose fiber when distances are long. Anything above 100 meters, we start implementing fiber optic, and for good reason. When I have a lot of electrical noise, lots of EMI issues, electromagnetic interference, or RFI, radio frequency interference, we typically install fiber optic to avoid those problems or minimize those problems. We typically use fiber optic between switches, between classes, between switches in our network, so basically the backbone of our network. That's typically fiber optic. I also tend to use fiber optic between closets for electrical isolation. Hopefully you remember from when we were talking cabling structure a long time ago. As we start connecting closets together, floor to floor in a building, we tend to use fiber optic between them. That way an electrical problem in floor 1 does not use the cabling and travel up to floor 2 in our building, in our equipment closets. So a lot of times between equipment closets, fiber optic is used to isolate those closets. It's preferred when we're thinking future upgrades. Again, down the road, what are we going to need? We don't know. There tends to be kind of the let's lean towards putting fiber in because we'll eventually need that. Alrighty. A lot of our decisions, though, are based on economy. So a lot of things we put in today tend to be, well, we're going to err on side of copper because if you start thinking about it, my computer has a twisted pair Ethernet port in it already. My server has a twisted pair Ethernet port in it already. The switches in my closet have a twisted pair Ethernet port in it already. The routers in my closet have a twisted pair port Ethernet in it already. So a lot of times we're making decisions on economy of like, well, we already have all that in place. Why change that? But they also mentioned that you can actually, in some environments, save a lot of money by installing fiber everywhere because I need less closets, I need less equipment racks, if you will, connecting things together. So there's times decisions are made for various reasons, and the book's actually trying to bring some of those ideas up to you, or some of those issues up to you. And one of the last ones they mention is your fiber optic ports and fiber optic transceivers actually use a fraction of the power that copper does. So kind of thinking down the long run, a lot less power usage. All right, for fiber optic standards, we have a couple we're going to touch on, but the first one they mention is our National Electrical Code. Chapter 770 of the National Electrical Code is the only mandatory standard for fiber optic cable plant installation. So if I look at my electrical code, 770, optical fiber, we had actually talked about some of these earlier systems before, but our 770, that's the one dealing with fiber optic, so this will be the one dealing on electrical and fire safety, if you will. That's the only one that's mandatory for install. But there's other standards we follow. The ANSI TIA standards were developed for standards for components and testing of fiber optic. And hopefully remember, as we talked about our ANSI TIA 568C3, that's the fiber optic section of our TIA 568 standard. The C3 section, these are based on a lot of the electrical code and electrical code and fire safety standards. So more than likely, if I install to this standard, I'm meeting all the other ones. But our 568C3 is about the components, the standards for components and the testing of them for our fiber optic systems. The other ones that were developed were our IEEE standards for interoperability. And again, the idea here is if I have a 1000 base SX port on a switch and I connect another switch that's a 1000 base SX port, those two are talking the same and going to work the same because they're using the same signaling, same wavelength, same bit rate, the whole 9 yards. They should be interoperable and work. So we need to remember the IEEE standards, and more specifically IEEE 802.3Z, these standards for gigabit fiber, gigabit over fiber, I'll get it out yet. And these are ones hopefully you should remember from 120. The 1000 base SX, LX, EX, and so forth. Don't get too bogged down in these, but do remember that these are the ones, your short wavelength, long wave, extended reach wavelength, and as we go, our bandwidths go up. or I should say, excuse me, the wavelengths get longer so that I can get longer distances. So I put a quick summary chart here for you to help you with keeping these straight, hopefully remembering these from 120. Any other IEEE we want to remember is IEEE 802.3AE. This is your 10 gigabit Ethernet over fiber optic. Your 10G base SR, LR, ER. Again, short wavelength 850, long wavelength 1310, extended reach or extra long wavelength 1550. And you'll notice as the wavelength gets longer, so does the distance capability of this signal. The distance capability of that signal, if you will. Okay, so the main one we got to follow is your National Electrical Code, and then your ANSI TIA is for the components and testing, and then the IEEE is for your interoperability. The other thing they mention here, and this is actually a worthwhile one to recognize, is the fiber optic standards, your fiber optic association, fiber optic association. This was developed as a resource for installing fiber optic systems and also for training too. If you actually visit the fiber optic association website, there's actually training and things on there to help with understanding fiber optic systems and all. Alright, the next section they talk about is actually dealing with fiber optics and installing it. This is literally just kind of touching the base on it. Later chapters will come back into some more detail, and we'll even work on doing a termination in our lab. They talk about some of the tools. A lot of the terminations you guys would actually encounter are actually in the form of a fusion splicing system, where the fusion splicer either splices together two fibers that you have, and or will fusion splice on a termination, a connector onto the end of a fiber. So a lot of the terminations you guys might actually encounter would be in this form, using a fusion splicing toolkit and using a fiber cleaver to prepare your fiber, and then actually putting it into your fusion splicer and having it either splice the fiber together or splice the fiber onto a connector that you load in the other side. And that'll be the tools and the terminations we'll be dealing with. They remind us on safety. Yes, with fiber optic, you do have light sources, some strong light sources, and even some laser light sources. So they remind us about some of the light sources we deal with could be very strong, especially the outside plant, and either use low-powered LEDs. Actually, premise uses low-power LEDs, but your outside plant might use actually laser. So we have to be careful of that, because that can potentially do eye damage. They do actually make special safety glasses that are designed to shield your eye from that. But where the problem comes in is if you actually end up inspecting the terminations with a microscope here, extreme caution must be made to make sure that the cable on the other end, the fiber cable on the other end, is actually disconnected, so that you do not have that light source coming through the microscope and being focused into your eye and do some damage to your eye. So some safety there with light sources in your fiber optic. The other thing they mention with terminations, and this is something we will talk about as we do our terminations, the continual exposure to small scraps of bare fiber as you're terminating. As we look back here, we use the fiber cleaver a lot. You prepare your fiber, lay it in here, and actually cleaves the excess fiber off, and it should be pulling it into the little reservoir here on the end, but that is a piece of glass stub that needs to be dealt with correctly. So as we're dealing with fiber terminations, we have those scraps we have to deal with. We should be wearing our safety glasses. We need to dispose of these correctly, and we're not eating or drinking near this. We don't want to ingest any of those fiber scraps that we're dealing with. Alright, that'll give us a good place to pause. When we come back, we'll talk about the fiber optic network section.